Assalamualaikum warahmatullahi wabarakatuh. Good morning, good day, good afternoon, good evening, everyone, everywhere in the world. My name is Irfan Yunianto, and in this special occasion, I would like to share about the reorientation of STEM learning to improve scientific communication. So I would like to start with the PISA scores in 2022. Sorry. So for those of you who are not familiar with what PISA is, PISA stands for Program for International Student Assessment, conducted by OECD in about 81 countries. And the latest one is in this year, 2025, but the result is not being announced yet until maybe the end of this year or at least early of next year. So this PISA score is a standard of how the world measure the students' performance in science, math, and reading skills. So in 2022, Indonesia ranks 69 out of 81 participating countries. So not only OECD member countries, but also non-member countries were being tested. And this PISA test is targeted to the grade 8 student in our school system. So it would be in junior high school. And according to the PISA scores in 2022, the number one country who is ranks one is Singapore. And Indonesia is unfortunately just slightly better than Philippines, but still lower compared to Malaysia and Thailand. So why do we need to talk about STEM education? Of course, PISA scores is relevant with our STEM education. And talking about the STEM education, of course, you have been aware that STEM stands for science, technology, engineering, and math. It's not a new topic for us. At least more than decades ago, this topic has been initiated and has been taught in the schools, mostly to integrate between the science, technology, engineering, math, but even it is being expanded into STEAM, for example. The letter A stands for art, and even also integrated with R stands for reading. So maybe the most popular term today is STREAM: science, technology, reading, engineering, art, and math. So why we need to reorientate our STEM education? As we might have been aware that our STEM learning in the schools, probably by using the project-based learning model, still giving priority to the result or maybe to the portfolio that will be provided by the students. We may need to be more to give more priority to the upstream, which is how we can introduce the STEM learning in the class with a different approach. So I'm going to talk a little bit about the 3D learning from NGSS. You may have heard about the NGSS, which stands for Next Generation Science Standard. It is a science curriculum which has been developed and conducted in USA. So the 3D stands for three-dimensional, of course. So what makes this learning approach different from our regular STEM learning in the schools? So the 3D learning, I put the word CER here, stands for the claim, evidence, and reasoning. It's basically how we approach the STEM learning in the class using the three topics, which is the DCI, stands for disciplinary core themes or disciplinary core ideas. And then the SEP stands for the science and engineering practices, and along with the triple C or cross-cutting concept. So basically, I will give you an example. When we learn a particular topic, for example, in biology, about the homeostasis, for example. So the core or the idea is learning about the homeostasis. And then comes the science and engineering practice. So how we can solve the real world problem by setting up a real experiment regarding the homeostasis. And then comes the triple C or cross-cutting concept. Well, basically the triple C or cross-cutting concept is an idea to integrate multidisciplinary ideas. When we are learning about homeostasis, for example, we are not just learning about biology, but we also learn something else from the perspective of engineering, for example, from the perspective of chemistry or physics. So we can integrate all those multidisciplinary ideas to, conduct an experiment to solve the real world problem regarding the topic of homeostasis, for example. And this 3D learning from NGSS actually has been implemented in at least 5 Southeast Asian countries. And Indonesia is also one of them. The other countries are Malaysia, Thailand, and Cambodia and Kazakhstan. So we are currently engaged with the international project under the SEAMIO STEM-ED, which stands for the Southeast Asian Ministry of Education Organization, the regional STEM Education Center. The project has been implemented also in our school partners, and we conducted this project in our 3 Muhammadiyah school partners, and we are quite confident because even though we initially we conducted the workshop for the teachers, but then the teachers can implement the principles of the STEM learning through the CER frameworks by themselves in their classrooms. And we found the great improvement in science learning experience. So not just the science learning itself, but most importantly, how the students experience science. Because you see, like the project-based learning, for example, of course, the student also enjoy the STEM learning process. But we need to be more focused on how the student can solve the real world problem. So they can ask the correct question. They can ask we call it the driving question, because based on this question, it drives them to think about the experiment they need to conduct to solve the problem or to answer the question. So actually, in short, we ask the student to learn as a scientist. So what makes the difference between the scientist, the real scientist working in the lab, with the student learning science in the classroom? Well, actually, there are no differences. Only maybe the facilitation of the laboratory, of the equipment, but the principle of science is the same for the scientists in the lab with the 8th grade junior high school students. They're all the same. So one more thing that we found quite improvement. It's not just about the experience of learning science in the school, but also the improvement of at least these 4C skills, which include the critical thinking, creativity, collaboration, and also communication. So if we look at this 4C, if we look at this 4C, critical thinking, this is actually where the reasoning part comes. Because we want the student to be able to make claim. Claim is a statement of the question or of the phenomena that they need to answer. So they make a claim, but they also have to prove it through an experiment. So after they make a claim, they can provide the evidence. They also need to make reasoning, which is a scientific explanation or scientific justification which connect the claim and evidence. So that's where the CER comes, right? And then the creativity. Of course, we need to also improve the students' creativity by doing a real experiment, by making scientific modeling. We encourage the student to think deeply. Well, this is actually in line with the deep learning. And we encourage the student to also discuss with their friends, with their peer. So that's where the communication and collaboration skills of the student will improve. So basically, using this 3D learning from NGSS with CER framework is a good reorientation of our STEM learning. So hopefully this can be expanded, and we in Universitas Ahmad Dahlan is ready to conduct this framework on the STEM learning everywhere, including in our school partners. So to sum up, reorienting STEM education in Indonesia is crucial to improve scientific skills and communication through the implementation of the NGSS 3D learning, which include the disciplinary core ideas, science and engineering practices, and also cross-cutting concept. And we are confident that through this approach, the students' critical thinking, creativity, communication skills, and also the collaboration will also improve. So I think that's all for me. Hopefully it will give a new insight. And thank you very much. Assalamualaikum warahmatullahi wabarakatuh.